Good day, everyone. Today, I will discuss the Bernoulli distribution. And our learning objectives are to develop clear understanding on Bernoulli distribution and to solve for the mean, variance, and moment generating function of this distribution. Let us start with its definition. As stated, a random variable x is defined to have a Bernoulli distribution denoted by this symbol x follows BE times P if its probability mass function is as follows. So we have this equation for the PMF of a Bernoulli distribution. We have f sub x of x equal to p raised to x times quantity 1 minus p raised to 1 minus x, wherein we have two possible outcomes only. So the possible outcomes for this distribution is only 0 and 1. So we have to remember this. The outcomes for the Bernoulli distribution is just 0 and 1. And also remember, the probability lies between 0 and 1 as well. So for us to better understand why we have only two outcomes here, so as stated in the formula for the PMF, we have f sub x of x equal to p raised to x times quantity 1 minus p raised to 1 minus x. And as stated, x can be 0 or 1. So if we will use x be equal to 0 and 1, wherein 0 stands for the failure and 1 stands for the success, what is the value of f of x? So we will use this formula. So we will try to determine the value of f of x here. So we will be using the equation for the PMF, which is the f sub x of x equal to p raised to x times quantity 1 minus p raised to 1 minus x for us to know the value of f of x. So let us first try to get f of 0. So to be able to get f of 0, so we have this computation. As you can notice, we have substituted 0 to all the x that we can see in this equation. So we have x as 0, then the exponent of p raised to x became 0, then the exponent of 1 minus p, instead of having 1 minus x, we have 1 minus 0. And we know that any number or any number that is being raised to 0 will give us just 1. So p raised to 0 is just 1. Then since 1 minus p will be raised to 1 minus 0, which is also 1, it means that we just have 1 minus p here. Ano po? So 1 minus p times p raised to 0, which is 1. So 1 times 1 minus p, and that is just 1 minus p. So meaning to say, f sub x of 0 is just 1 minus p. So take note of that. So f uh, of 0 is 1 minus p. But what about f of 1? So what if we will substitute 1 to all the x that we can see in the equation for the PMF of a Bernoulli distribution? So allow me to share the computation. So we have the formula for the PMF. So we will use f sub x of x equal to p raised to x times quantity 1 minus p raised to 1 minus x here. Then let us substitute all the values of x as 1. So x, ayan. So instead of f sub x of x, we have f sub x of 1. Then p raised to x became p raised to 1, and 1 minus x became 1 minus 1. And 1 minus 1 is 0. So since that is equal to 0, if we will raise 1 minus p to 0, that will just result to 1, and p raised to 1 is just p. It means we will multiply p raised to 1 with p, and that will give us p only. It means that f of x of 1 is just equal to p. Hence, f of 1 is equal to p. And with that, using the equation for the PMF of a Bernoulli distribution, we now have the value of f of x of 0 and f of 1. And kindly take note of that. Always remember that in a Bernoulli distribution, our f of 0 is 1 minus p, and our f of 1 is p. Okay? So always take note of this representations. Now, we have this theorem. According to this theorem, if x follows BE times P, then the formula for our mean is E of x equal to P. And the formula for the variance, represented by var of x, is equal to PQ. And the formula for our moment generating function, represented by m sub x of t, is equal to pe raised to t plus q. So this is the equation that we will be trying to solve later. So we will try to show how we come up with e sub x of p equal to p as the formula for our mean, and how we come up with the var of x equal to pq, which is the formula for our variance, and at the same time, to show how we come up with m sub x of t equal to pe raised to t plus q as the formula for our moment generating function. Okay? And a while ago, I asked you to note that f of 0 is equal to 1 minus p and f of 1 is equal to p. So we will be using that representations later. And with that, let us move with the next slide, wherein we will try to show how we come up with e of x equal to p as the formula for our mean, and at the same time, we will also compute for the variance. Okay, so let us start with the mean. So we know that for us to have the mean, or e of x, our formula will be summation of x times f of x for all x. And if you can still recall, the values of x in a Bernoulli distribution can only be 0 and 1. So it means that in getting the summation of x times uh, in x times in x times f of x, we will start with x equal to 0 up to 1. And with that, we have, okay, x, we substitute 0 for x, and we have 0 f of 0, or 0 times f of 0, plus we have 1 here, since that is imaginary, okay? So x is 1, and that will be imaginary, then f of 1. Note that a while ago, we have f of 0 equal to 1 minus p, and f of 1 equal to p. So with that, we will be substituting that here in our computation. So we have 0, and we have f of 0 as 1 minus p. So we substitute 1 minus p for f of 0, and we substitute p for f of 1. So we have 0 times 1 minus p plus 1 times p. And multiplying any number with 0 will always result to 0. Hence, we only have 1 times p, and 1 times p can only give us p. So with that, it is true that in a Bernoulli distribution, if x follows be times p, then our mean is equal to p. Okay? So, ayun po. Now that we are done showing that the mean of a Bernoulli distribution is E of x equal to p. Now let us try to show how we come up with the var of x equal to pq, okay, which is our variance. And we know that for us to have the variance, the formula is equal to E of x squared minus the square of E of x. So for us to have this, we still have to get x squared times f of x, summation of x squared times f of x, and as stated a while ago, in a Bernoulli distribution, we only have 0 and 1 as the values of our x. So we will start with x equal to 0 and up to 1. Okay, so we have summation of x squared of f of x from x equal to 0 up to 1 minus p squared. And how come that it is p squared? If you can go back here, our e of x, or our mean, is equal to p. So with that, we just get its square. And the square of p is p squared. Okay, now let us proceed with the continuation of this computation. As you can notice, we have substituted 0 and 1 for the x. So on the first one, 0 squared times f of 0 plus 1 squared times f of 1 minus p. So this represents a summation of x squared of f of x from x of 0 up to 1. And we are still going to use this representations that f of 0 is equal to 1 minus p and f of 1 is equal to p. So we substitute 1 minus p with f of 0 and p for f of 1. And now we have, okay, why do we have p minus p squared only here? So take note that any number that we multiply with 0 will just give us 0. So meaning to say, 0 squared times 1 minus p. Okay, so this one will just give us 0. Then 1 squared is just equal to 1. So that is just 1 times p, which is equal to p. Then we copy minus p squared. And take note that may we may have p as the common factor for p and p squared. So with that, ilalabas po natin yung p, which is the common factor, and we will have p times 1 minus p. So this is an equivalence of p minus p squared. And let us let q be equal to 1 minus p. So since q is equal to 1 minus p, 1 minus p will be q. Hence, our variance is equal to pq, okay, or the product of p and q. And that is true for what we have in the theorem, that variance is equal to pq in a Bernoulli distribution. So they are the same. So we're able to show the, how we come up with the mean and variance. And on the next slide, we will try to show how we come up with the moment generating function of a Bernoulli distribution. So let us move with the next slide. So we're done with the mean and variance. And now let us try to show how we come up with m sub x of t equal to p e raised to t plus q. Okay, so as you can notice, we will be using this formula to get the moment generating function, which is the m sub x of t equal to e times e raised to dx. And with that, since the value of x can only be 0 and 1 only, it means that m sub x of t is equal to summation of e raised to tx times f of x from 0 up to 1. Okay? So again, we only have 0 and 1 as values of our x. Now let us substitute. Okay, so for e raised to tx, so we have e raised to t times 0 times f of 0. Then, let us substitute 1. So we have plus e raised to t times 1 times f of 1. So since this is 0, okay, so since this is 0, so e raised to t will be just equal to 1, and that will not affect f of 0. Okay? So ito po ay 1 na lamang, and as uh, identity, so it will not affect f of 0. So kung ano si f of 0, yun pa rin siya. So f of 0 is equal to 1 minus p. So we have 1 minus p here. Then how do we have e raised to t p? So e raised to t times 1 is just e raised to t. Then we have f of 1 equal to p. So we have e raised to t times p. And take note that we let q to represent 1 minus p, right? So 1 minus p will be q. So with that, we have q plus e raised to t p. And that is what we want to show. Okay, so now we're able to show that if x follows be times p, then the moment generating function of a Bernoulli distribution is equal to q plus et times p. So though we have the arrangement not that the same, so same pa rin naman since that is commutative. Okay, and with that, thank you for listening. Bye.